Since the beginning of time, Earth has lived under a silent threat, one that drifts through the cold void of space, invisible to the creatures living below, yet powerful enough to rewrite the story of the entire planet. These are asteroids, remnants of creation, fragments of ancient worlds, messengers of both destruction and possibility. Human beings often imagine Earth as stable, eternal, protected. But the truth is far more dramatic. For billions of years, Earth has been sculpted, scarred, shattered, and reborn through asteroid impacts. Entire species have vanished in moments. Continents have cracked. Oceans have boiled. Climates have flipped. And in the ashes of catastrophe, life has often risen anew, transformed forever. This is the story of how asteroids shaped Earth's past, threaten its future, and may one day determine our destiny among the stars. To understand their power, we must begin not on Earth, but in the chaotic dawn of the solar system, where everything we know first took shape. 4.5 billion years ago, before Earth existed, before the planets formed, there was only chaos. A swirling disk of dust, ice, gas, and fiery particles orbited the young sun, glowing like a ring of cosmic fire. This was the solar nebula, a giant nursery of future worlds. Inside this cloud, countless fragments collided. Some merged to form larger bodies. Some shattered into pieces. These pieces, some the size of mountains, some tiny as pebbles, became the first asteroids. The early solar system was a violent place. There are no stable orbits, no peaceful planets, no calm skies. Everything was constantly smashing into everything else. Imagine billions of rocks crashing, melting, breaking, and reforming. An endless cosmic storm that lasted millions of years. From these collisions emerged planetesimals, the seeds of planets. Gravity pulled them together into larger worlds. Mercury, Venus, Earth, Mars, and the giants beyond. But not all fragments found a home. Many remained as wandering debris, leftovers of creation. These are the asteroids we know today. Most settled in the asteroid belt between Mars and Jupiter, where the giant planet's gravity prevented a new world from forming. But others were thrown outward, inward, or into unstable orbits that sometimes crossed Earth's path. These wandering stones would become the greatest sculptors in Earth's history. When Earth first formed, it was not the blue, life-filled planet we know. It was a molten sphere glowing with volcanic heat, its surface constantly reshaped by falling rocks from space. The young Earth was struck again and again by massive impacts, some so large they vaporized oceans and melted crust. This era is known as the Hadean Eon, named after Hades, the underworld, because conditions were hellish. Asteroids hammered Earth for hundreds of millions of years. The planet was still soft, still forming, and every impact reshaped it. Many of the largest craters from this time no longer exist. The crust was too young to preserve them. Instead, they were swallowed, melted, or recycled into the mantle. But though the scars are gone, the consequences remain. These early impacts helped shape Earth's atmosphere. They delivered water-rich minerals that helped form the oceans. They carried organic molecules, simple chemical seeds that may have contributed to the origins of life. In a strange way, the same cosmic violence that nearly destroyed Earth again and again may also have planted the ingredients that made life possible. Yet, Earth's earliest and most powerful asteroid impacts were still yet to come. Among the largest known asteroid strikes in Earth's history is the Rewrote event, which occurred roughly 2 billion years ago in South Africa. The asteroid that hit Earth may have been between 10 and 15 kilometers wide, similar in scale to the one that would later end the dinosaurs. But the Rewrote impact was even more massive. The explosion carved out a crater nearly 300 kilometers across, making it the largest confirmed impact structure ever discovered. At the moment of collision, temperatures skyrocketed. The ground vaporized. Shockwaves traveled through the crust like ripples through water, altering geology for thousands of kilometers. Life at the time was simple, mostly single-celled organisms. Yet even they were affected forced to adapt to a world shaken by catastrophe. The impact may have altered atmospheric conditions, influenced ocean chemistry, and helped shape the future of life. A few 100 million years later, another colossal asteroid struck Earth, this time in what is now Canada. This event, known as the Sudbury Impact, was so powerful that molten rock splashed outward for hundreds of kilometers. The crater eventually eroded, but the geological deposits left behind include some of the world's richest nickel and platinum reserves, resources humans still depend on today. These titanic impacts did more than leave scars. They shaped Earth's crust, altered continental plates, and influenced the future evolution of life. Asteroids were not merely destroyers, they were creators. Around 540 million years ago, life experienced one of its most dramatic transformations. Within a short geological window, complex organisms exploded into existence. The seas filled with trilobites, early fish, sponges, worms, and countless new species. What triggered this sudden burst of diversity? Many scientists believe that asteroid impacts played an indirect role. Just before the Cambrian explosion, Earth experienced an unusual increase in impact activity. Small to medium asteroids struck the planet more often than usual. Though none were large enough to cause global extinctions, they may have created environmental pressures that forced life to adapt rapidly. Each impact stirred the oceans, kicked up dust, changed temperatures, and altered habitats, just enough to challenge early organisms but not destroy them. This balance of stress and survival may have accelerated evolution. Life flourished not despite asteroid impacts, but because of them. This pattern would repeat again and again in Earth's history. As the Paleozoic era ended and the Mesozoic began, Earth entered the age of dinosaurs. But their rise was not guaranteed. It was shaped by chance events, including asteroid impacts. Around 215 million years ago, during the Triassic period, a large asteroid struck what is now Quebec, Canada. This event created the Manicouagan crater, one of the best-preserved impact structures on Earth. The asteroid may have been around 5 kilometers wide, large enough to cause worldwide environmental effects. Though it did not cause a mass extinction on its own, it occurred during a time of ecological instability. Some researchers believe that impacts like Manicouagan contributed to the decline of early rival species, clearing ecological space for dinosaurs to eventually dominate the Earth. It is a reminder that evolution is not a straight, predictable path. It is shaped by catastrophe, by the random fall of rock from the sky. And the greatest catastrophe of all was still to come. 66 million years ago, on a warm and humid day like any other, the sky over ancient Mexico lit up with a blinding flash. A 6-mile-wide asteroid, moving faster than a bullet, entered Earth's atmosphere. In an instant, the age of dinosaurs came to an end. The asteroid struck the shallow waters of the Yucatan Peninsula with a force of over 100 million megatons of TNT. The explosion dug a crater over 180 kilometers wide and vaporized rock, ocean, and atmosphere. The moments after impact were apocalyptic. A fireball hotter than the surface of the sun erupted. Forests across continents burst into flames. Mega tsunamis surged across ancient oceans. Molten debris rained from the sky. Ash and sulfur filled the atmosphere. Sunlight disappeared for months or years. This plunge into darkness collapsed ecosystems. Plants died. Herbivores starved. Carnivores followed. 75% of Earth's species vanished, including the mighty dinosaurs. But in the shadow of destruction, life found a new beginning. Small mammals, hiding in burrows and feeding on insects, survived. Freed from dinosaur dominance, they evolved, diversified, and eventually gave rise to primates and humans. We exist because an asteroid destroyed the world that came before us. In the aftermath of the Chicxulub impact, Earth fell silent. For weeks, the skies remained dark. For months, the air remained cold. For years, the planet struggled to recover. But slowly, as the ash settled and sunlight touched the Earth once more, life began to return. Small plants, hardy grasses, and ferns were the first to reclaim the land. They grew across burnt landscapes, stabilizing soil and restoring oxygen levels. With the dinosaurs gone, new ecological niches became available. Mammals began to spread into environments they had never accessed before. Open plains, thick forests, mountain ranges, riverbanks. For millions of years, mammals had lived in the shadows, tiny, fragile survivors hiding from reptilian giants. Now they were free to evolve, free to dominate, free to become the architects of a new world. This was not just a rebirth, it was a transformation. And as mammals expanded, they slowly laid the foundation for the future evolution of primates, apes, and eventually humans. Ironically, the asteroid that destroyed one world also made room for the next. It wiped out the rulers of Earth, but in doing so, cleared the stage for new life to step into the light. Asteroids take, but they also give. They shatter ecosystems, but they create opportunities. They destroy civilizations, but they open pathways for new ones. The Earth that emerged after the Chicxulub impact was not the same planet as before. It was a world reshaped by fire, reborn through chaos, and ready for a new chapter in the story of life. Millions of years after the extinction of the dinosaurs, Earth continued to face asteroid impacts, some smaller, some devastating, but all powerful reminders of our planet's vulnerability. Around 35 million years ago, during the late Eocene epoch, two major asteroid impacts shook opposite sides of the planet within a relatively short span of time. The first struck what is today the eastern United States, forming the Chesapeake Bay crater. At the time, the region was covered by warm, shallow seas. When the asteroid, estimated to be nearly 3 kilometers across, plunged into the water, it triggered megatsunamis that swept across ancient coastlines. The impact carved a crater more than 85 kilometers wide, and its effects can still be traced in the geology of the area today. The second impact occurred in Siberia, forming the Papagai crater. This asteroid strike was far larger, roughly 8 kilometers wide, and released more energy than the explosion that killed the dinosaurs. The impact transformed carbon-rich rock into vast layers of industrial-grade diamonds. For decades, these diamonds remained hidden beneath the remote Siberian landscape, undiscovered by humans until modern times. These two impacts, though separated by continents, may have contributed to significant climatic shifts. The late Eocene period experienced cooling trends that eventually led to the formation of the Antarctic ice sheet. Some scientists argue that repeated impacts during this era may have played a role in triggering this environmental transformation. Asteroids continued to shape the Earth millions of years after the dinosaurs, but now the world was being prepared for the rise of primates, early hominids, and ultimately humans. When the ancestors of humans first appeared, Earth was already a museum of ancient catastrophes. The land they walked was shaped by craters older than mountains, older than oceans, older than the species themselves. Early hominids roamed across landscapes formed by asteroid scars. The African continent, where humanity originated, contained ancient impact basins hidden beneath forests and deserts. The Indian subcontinent, long shaped by tectonic collisions, bore subtle traces of cosmic impacts. Asia, Europe, and the Americas all carried the faint signatures of long-forgotten strikes. Our ancestors lived in a world sculpted by asteroids, though they had no concept of the forces that had shaped their environment. To them, the sky was a realm of gods, spirits, and mysteries. A falling star was a sign. A meteor streaking across the night was an omen. Rare but powerful, these events inspired mythologies that stretched across cultures. African tribes spoke of fiery stones that fell from the heavens. Ancient Greeks believed that the gods hurled stones of light across the sky. Aboriginal Australians passed down tales of burning objects that carved out lakes and craters. Native American tribes told stories of fire falling from the sky as punishment or renewal. Long before humans understood science, they understood awe. They understood fear. They understood the overwhelming power of nature. But little did they know, the greatest cosmic threats still lay ahead. On the morning of June 30th, 1908, in the remote Siberian wilderness near the Tunguska River, the sky split open. A blinding flash, a burst of heat, a shock wave that circled the globe. An asteroid, or perhaps a small comet, only 50 to 60 meters wide, exploded in the atmosphere with a force of 15 million tons of TNT. Though it never touched the ground, the explosion flattened over 2,000 square kilometers of forest. The sound was heard hundreds of miles away. People were thrown off their feet. A shockwave shattered windows across continents. Night skies glowed for days afterward. If the object had exploded over a city instead of a remote forest, millions could have died. The Tunguska event was a message, a reminder that even relatively small cosmic objects can unleash catastrophic destruction. Scientists at the time were puzzled. They found no crater, no impact site, no fragments large enough to explain the devastation. For decades, theories ranged from volcanoes to alien spacecraft. Only in the late 20th century did researchers confirm it was the atmospheric explosion of a stony asteroid. Tunguska was a warning shot, but humanity did not yet understand the scale of the threat. Another reminder would come more than a century later. On the cold morning of February 15th, 2013, the people of Chelyabinsk, Russia, woke up expecting a normal day. Instead, the sky erupted. A meteor roughly 20 meters wide entered the atmosphere at incredible speed. As it streaked across the sky, it glowed brighter than the sun. The shockwave from its explosion shattered windows throughout the city, injuring over 1,000 people, mostly from flying glass. Car alarms blared. Buildings shook. People ran outside in panic, filming the event on their phones. Within minutes, dashcam videos from across the region went viral, making Chelyabinsk the most well-documented meteor event in history. The Chelyabinsk meteor was significantly smaller than the Tunguska object, yet its explosion released energy equivalent to 30 Hiroshima bombs. If it had exploded just a few kilometers lower in the atmosphere, the city might have faced far greater devastation.